Okay, so I'm going to prove the derivative of arc cosine equals that. So I'm going to start off by letting y equal the argument, which is arc cosine of x. After that, I'm going to take the inverse. So that's going to be x equals cosine y. To do the inverse, you just switch the x and the y, and then of course the inverse of arc cosine is just cosine. After this, you do implicit differentiation. So you take the derivative of x equals 1, derivative of cosine, so negative sine y, and then after you take the derivative of anything with the y, you have to chain out the dy dx. You have to get the dy dx on its own side, so by doing that, you're going to have to just divide the negative sine y over. So you have dy dx equals 1 over negative sine y. After this, you can take your denominator, and it's a Pythag identity of sine squared y plus cosine squared y equals 1. So you're going to get sine on its own side because that's what we have in the denominator. So by doing that, you're going to subtract over the cosine. So sine squared y equals 1 minus cosine squared y. Because they are squared, you're going to have to do the square root of both sides to cancel out this square. So you get sine y equals square root of 1 minus cosine squared y. So we just solved for sine y, so you can take this and plug it back in. So it's going to be 1 over negative 1 minus cosine squared y. After this, your cosine squared y is technically equal to, or it is equal to, cosine y times cosine y, cosine times itself. And up here we established that cosine y was equal to x. So that is x times x, and x times x is equal to x squared. So I'm going to take this, I'm going to plug it back in for cosine squared y, which is what we just solved for. So you get 1 over negative 1 minus x squared. Then I'm just going to take this negative, push it out to the front so it's not in the denominator. So that gives you your final product of negative 1 over square root 1 minus x squared. And that's what we were trying to solve from the very beginning.